All right, guys, it is time to learn the last parent function, tangent. So a couple things to note about when we're graphing cotangent and tangent functions. On sine, cosine, secant, cosecant, the period was always 360, right? Going off of the unit circle, they didn't start repeating values until 360 degrees. If you look at the unit circle, you'll see that tangent, which is sine values over cosine values, start repeating every 180 degrees. So that is why the period for tan and cotangent is 180. So we do need to be careful about that when we're trying to find our period for our function. So we're looking at this function. We're going to do some shifts a little bit later, but let's start with this guy. So this one is going to be our amplitude, and then this guy here with the theta or the x affects the period. So with this, we know technically that is the amplitude location. However, because of a tangent graph, there is no amplitude. It goes on forever in both directions, right? So that too does affect the curve of our, how steep. Is it going to go more flat and then up? It does affect that, but it's so hard to visually see that when we are graphing these, when we're just sketching the graphs of these, which is what we're going to be doing, we don't even identify a difference on those guys. So yes, where the amplitude part is too, but when we're asked in the questions what the amplitude is for cotangent and tangents, we are saying none because there is no ending point on these guys, okay? The period, instead of always taking 2 pi and dividing by that coefficient with the x or the theta, we are going to take a pi and divide it by, in this case, it's just 1. So 1, we get 180. And then in sine, cosine, secant, cosecant world, we took this value and we found that something important was happening every this divided by 4, right? Not in tangents and cotangents, because this is 180 degrees. So we either have an asymptote or a 0, an asymptote or a 0. So we're just dividing this guy by 2, which makes sense because the period is half of what it was. So instead of dividing by 4, we're going to divide by half of that, which is 2. So we know we have something important happening every 45 degrees. I'll get rid of this 2 so it doesn't confuse us on our period. Okay. We're not doing shifts yet, so we don't need to worry about that. Okay, we're going to use the starting point of 0 on all of these, like where the x and y axes cross, okay? I'm going to do a little sketch like I always do for tangent. Tangent is going to go through the origin and go up, okay? So at this spot where the x and y grid cross, what is it? Is it an asymptote or is it a 0? It's a 0. So we're going to put a 0 there. Okay, we said that our period for this function was pi. So we are going to have a 0 every pi distances from this guy. So from 0, it's going to be pi. From 0, it's going to be pi. Oh, 2 pi, sorry. And then from this 0 at 2 pi, we're going to be at 3 pi. Okay, I'm going to do it at negative pi. Goes on infinitely in both directions. Okay, so periods mean when it starts to repeat. So this would be a repeating part, right? Because it's going to go here and then it's going to go down and then up. So it starts repeating every time. Halfway between the zeros, which are the dots we have plotted, are asymptotes. So between 0 and pi, what is that distance? Half of that. Well, pi over 2. So we're going to draw an asymptote at pi over 2. Okay, got our asymptotes, got our zeros. It is a positive. 2 has no real effect for us. So the way that we draw these, this is one that students struggle a lot with. So I kind of think about it as like it's half of a parabola going up, like from what would be the vertex. These are not parabolas, but they kind of look like it. And then it's the negative of it. Just an easy way to graph those guys. They go close to the asymptote, but don't touch it. So the only thing we're really looking for here is the general shape. Is it a positive or negative, increasing or decreasing function? Where are our asymptotes? And where are all of our zeros? Okay, if we have the general shape, zeros and asymptotes in the right location, then we can figure this out. Easy peasy. Okay.